inequalities. We're going to determine what kind of methods and basically which kind of cases there are for absolute value inequalities and how to solve them. It's one of the more complicated things we're going to do this year because there's a little bit more rules to it. So there's the less than case, or we call that a conjunction. So what we're going to first do is we're going to do just like with the equations, we're going to figure out if our absolute value is all by itself on one side of the inequality sign. I mean, it's isolated. Ours is. Once we do, we check to see if the sign right after it is a less than equal to, or a greater than equal to. In this case, it's a less than. So this case, conjunction, only works with less than and less than equal to signs when you have the absolute value on one side and something on the other side. So you have to isolate it and then check the inequality sign. Since this one indeed has the less than, we are going to go through and we are going to solve it using the less than or conjunction case. How do we do that? Well, it's called the sandwich method. We take what's inside or isolated in the absolute value and we put it between that less than or less than equal to sign. We sandwich it. And then we put the negative of this number out here and the positive at that end. So we're saying that it can go in either direction 3 spaces. So either the positive 3 or negative 3. This is called a compound inequality. And we just normally solve that, as we did in Algebra 1, for x. Since we want x by himself in the middle, we're going to add 4 to all 3 parts. Negative 3 plus 4 is 1. 3 plus 4 is 7. So that means the answer to this inequality is between 1 and 7. What does that look like on a number line? From 1 to 7, we're going to have open circles, because there's no lines under those inequality signs, and it's sandwiching or filling in or shading all the numbers in between. That means every number between 1 and 7, such as 2, 3.4, 6.5, all of those are going to be answers to this equation. So again, our goal was isolate and then check to see if it's a less than or less than equal to sign. If it is, we sandwich. That's what conjunction is having us do, is sandwich. All right, well, now I'm going to try what I think is going to be a greater than or a disjunction case. So again, I have to check to make sure, first of all, that it's isolated. And then the absolute value or the inequality sign after there is a greater than. So this is for greater than or greater than equal to. Now this one, if it's greater than or greater than equal to, you do not sandwich. This one makes you kind of pop it apart into 2 different equations. So the first one is what's inside is greater than what's outside. Well, that makes sense. That's what it looks like. But here's where it gets really weird. The next equations, or inequalities, I'm sorry. It's what's inside is less than the negative. Yep, it's a flipping. And what this does is it's saying that it can be nowhere in between 7 units because it's greater than 7 units away. So it has to be 7 units or more or less than 7 on the other side, which is negative 7. Once you have that, you're going to solve this. So I'm going to subtract 5 on both sides. Divide by negative 2. Oh, remember when you divide by a negative, you flip the inequality sign. Minus 5 on both sides. And remember when you divide by a negative, you flip the inequality sign. So what does this look like on a number line? You've got -1, and over here you've got +6. At -1, it's an open circle, and it's everything smaller than -1. So you shade the smaller. Over here, you get an open circle for 6, and it's everything bigger than 6. Notice these are pointing away from each other. Disjunction, greater than case. That means nothing can be here in the middle. There's nothing here in the middle that is an answer. Nothing. Only the things that are smaller than -1, like -2, -100, and bigger than 6, like 10 or 5,000, are answers to this solution. All right, let's try another one. Now this one, I didn't even put which case he was because, like I said, you have to isolate to find out. So is he isolated? No. We need to move the 5 over to the other side. So I get the absolute value of 2x plus 3 is less than equal to 15. Now that he's isolated, I can clearly see that he is the less than or less than equal to. That's a conjunction case, which means I take what's inside and I sandwich it between the positive and negative of what's on the other side. Remember, this is a sandwich. And then I solve. So I'm going to get x by himself. I'm going to have to minus 3 from all 3 parts. X negative 18 less than equal to 2x less than equal to 12. Divide all parts by 2. Which gives me negative 9 less than equal to x less than equal to 6, which again, if I'm putting that on a number line, from negative 9 to positive 6, at negative 9 we got that little equals to down there, so I'm going to fill in my circle, and it's same thing at 6, I'm going to fill in my circle. And sandwich means everything in between are my answers. Everything from negative 9 to positive 6 is an answer, and nothing else. Why don't you try in your interactive notebook, that's over on the left side of your page in your notebook, I want you to try this absolute value inequality. Now make sure you isolate it first, then figure out if it's a greater than or a less than case. And then solve the inequality and graph it. Good luck.